All right, in this video, we're going to talk about the geometry definitions that we're going to use in Unit 5. So this is going to be mostly a review for the day. Okay, so this is where we're starting. We're going to visit a lot of our definitions that we talked about in Units 1, Unit 2, Unit 3, Unit 4. Okay, so we're going to start here with some definitions. Okay. What I'll do is I'll go through just this slide and show you some things that we're going to talk about. Okay, so here we need to know what the word congruent means. Okay, so we're going to talk about congruence. We're also going to talk about what the word corresponding means. Okay, so we're going to go back. We're going to visit those two things. With congruency, we're going to talk about the symbol for it and what it means for our shapes, okay? Here on this slide, okay, there are a bunch of definitions that we're going to use, okay? So we need to revisit the definition of midpoint, the reflexive property, vertical angles, alternate interior, alternate exterior, corresponding, and angle bisector, okay? So these are all of the things that we're going to review in this first portion of the unit. Okay, so we're just going to work our way from the top down. And the first one was congruent. Congruent. So when we have something that is congruent, okay, what does that mean? Congruent. Congruent, when we talk about something that's congruent, that means that it is the same size, okay, the same size and the same measure. Same size, same measure. Okay, you may have heard same size, same shape. That is true. Okay, but when we talk specifically about congruent for us, it's mostly same size and same measure. Okay, and with congruence or congruency statements, okay, we have a symbol that we will see. So the symbol is this little squiggly, it's like an S flipped on its side. And then underneath it, we have the equal sign. So if you see this right here, this means congruent. Okay. So congruence, this is what the entire unit is about, congruence in triangles. Okay, so we're going to be dealing with this symbol. We're going to be dealing with things of congruency quite a bit. Okay, the next thing that was on our list was corresponding. Corresponding. Okay, when something is corresponding, that means that it's in the same position, right? This is from our parallel lines unit. Corresponding means same position. Okay, corresponding means same position. So there's a few different ways that we're going to use corresponding in this unit. Okay, the first way would be with parallel lines. Okay, so with parallel lines, if I have two lines that are parallel, like this, and then there's a transversal line that cuts through them, okay, the corresponding angles could be right here where it says 1. Okay, so these would be a pair of corresponding angles. You could also have a pair of corresponding angles right here where it says, oops, I'm in the wrong drawing mode, where it says 2. Okay, another pair of corresponding angles would be right here where it's 3, where I have the blues. And we also could have this in brown where I put the 4s. Okay, so corresponding is just the same position. So when I'm talking about same position with angles like this, okay, what we talked about was identifying them as in the top, in the bottom, on the left, or on the right. That's how we identified positions. Okay, so angle 1 is in the top. It's on the top of this transversal, and it's on the left side of this line. Okay, this angle 1 in red is also on the top of the transversal and the left of this line. Okay, so when we talk about corresponding with parallel lines, it's just the two angles that are in the same position. The other way that we are going to talk about corresponding is with congruency statements. So with congruency statements, typically what you're given is something like this. We'll just do triangle A, B, and C is congruent to triangle DEF. Okay, so remember, corresponding is the same position. So corresponding parts of congruent triangles, we're going to refer to the position in which these angles are listed out. So the way that that looks is all we're going to do is label the order of which these letters are listed. So A would be position 1, B is 2, C is 3. You come over to the other one, you have 1, 2, and 3. So the same position, the corresponding parts of this statement would be 1 and 1, 2 and 2, and then 3 and 3. Okay, so angle A in this case would be congruent to angle D because they're both in the first position. Okay, we'll talk more about this in the next video. So this takes care of all the corresponding things that we're going to talk about. Okay, so we've got congruent and corresponding. Now, the next thing was pretty much just all of the reasons why sides and angles can be congruent. So sides come first. That's the first thing that was listed. So we're going to talk about those. With sides, okay, for something to be congruent with the side, if it's given to you, you don't have to give some kind of definition, right? There's no need for that. So we're not going to talk about that. But the other one, the first actual definition would be the definition of midpoint. Okay, the definition of midpoint. So a midpoint, okay, we're going to break this down. A midpoint is in the middle of two other points. It's in the middle of two other points. Okay. So if I drew this picture here, and I just said that we have A and C, okay, and B is the midpoint between A and C, then what that does is it's saying that B's in the middle of these 2 points, and we can create 2 congruent segments, one from A to B and one from B to C. Okay, so in the midpoint creates 2 congruent segments. That is the biggest thing for this unit. So if you see something like this, where the picture is given to you and you have the hash marks like this, okay, that would be definition of midpoint. Also, if you are given something, a statement like this, I'm about to write it, but if it says that B is the midpoint of AC, then the midpoint is going to create 2 congruent segments. Okay, so B is the midpoint of AC. Okay, that is going to create 2 congruent segments. The first segment being AB, and then the second segment being BC. Okay, so that takes care of that. Now, the other thing that we need to revisit is the reflexive property. Okay, the reflexive property is super easy. Reflexive property. This one only goes with, for this unit, it only goes with sides. Reflexive property. So the reflexive property is when 2 sides, or when 2 triangles or shapes, it doesn't really matter, when we're just going to say shapes, when 2 shapes share the same side. Whoops. Okay, when 2 shapes share the same side, then we can say that that side is congruent to itself. So the shared side is congruent to itself. We can say that the shared side is congruent to itself. Okay, so that's how we're going to use a reflexive property. So if you see a picture that's something like this, okay, you have 2 triangles, and then you have this line that they both share. Okay, if you see this, AC falls into this category because both of these triangles share side AC, so AC is congruent to itself. So AC is congruent to AC. And then this would be the reflexive property. Okay, so that's how, if you see a picture like this, that's how you're going to use a reflexive property. AC is congruent to AC. This is my favorite one because it's the easiest to identify and it makes it quick. Okay, so that's reflexive property. I like the reflexive property. Okay, now next up we have all the reasons that angles can be congruent. Okay, so the next few examples are going to be referring back to all of the angles that are equal to each other. So the first one that we talked about this year was the vertical pairs or vertical angles. Vertical angles. Okay, the vertical angles, when we talked about these, okay, we made this right here. And we just put a V on the top and A on the bottom, and then we can spell out vertical angles. So vertical angles are congruent, and they are the opposite of each other. They just face each other. So vertical angles are congruent, and the way that you identify them is with a picture like this. Okay, so our picture is right here. So vertical angles are congruent. Okay, the next ones, these come from the unit 3 where we talked about parallel lines and transversals. Okay, so we already did corresponding, right? Corresponding was that first definition we did. So we're not going to go back over that. Okay, but we have a few others. We have alternate interior and alternate exterior. Alternate interior and alternate exterior. So I'm going to draw another picture. Okay, and this one's going to be for alternate interior. Alternate interior angles, okay, the definition breaks, or the word itself breaks down the definition. So alternate means opposite. And then interior means on the inside. So we have alternate angles that are alternate of each other. They're on opposite sides, and they are on the inside. They're inside the sandwich. Okay, so the way that I think about alternate interior angles is when you have the parallel lines, like these two shapes, or these two lines right here. Okay, that's the bread for a sandwich. Okay, so in here, this would be the inside of the sandwich. Okay, so these 4 angles would be inside the sandwich. We talk about this in some of the previous videos. So inside the sandwich is right here. Okay. On the outside, okay, I'm gonna do the outside in green. Okay, these are outside the sandwich. This goes with the alternate exterior. Okay, we'll talk about that in a second. So we have outside the sandwich here. Okay, so we have inside the sandwich or outside the sandwich. Green is outside, blue is inside. Okay. Now the other part, when we talk about the opposite, okay, the opposite goes with the transversal. Okay, so here in red, okay, this is our transversal. The transversal just cuts 2 or more lines. That's all that a transversal is. So the transversal, okay, is what determines the opposite. So if it's on the same side of the transversal, then you could have corresponding, or you could have same side interior. But if it's opposite, then we may be talking about alternate interior. So the transversal determines the opposite. Okay, so alternate interior. Okay, I'm gonna try my best to work around these. Okay, if I have this purple angle, okay, for the purple angle to be alternate interior, it has to be opposite of the red line. So it's going to be on the opposite side. So there's only two options here. It's either right below it or over here in this corner. Okay. If it's right below it, okay, that means that it would be a linear pair. Okay. The linear pairs are next door neighbors. They touch each other. Okay. So when we do alternate interior, they have to be on opposite sides and on the inside. So the other purple angle would go right here. Okay, so these two purple angles are alternate interior. You can also do the same thing with the black ones here. Okay, the two black ones are alternate interior. Okay, they're both inside the sandwich and they're on opposite sides of the transversal, the red line. Okay. Now for the last angle definition, we have the alternate exterior. Okay, so this one is, again, it's opposite because it's alternate. So we still have opposite angles of the transversal. We have opposite, and then these are exterior, so the exterior is outside. So I did not spell that right. O-U-T-S-I-D-E. There we go. Okay, so with this, we're talking about the angles that are circled in green. So if I'm going to choose just two random angles to work with, I could choose, do like this dark red here. Okay, if I choose this one, okay, this is on top of the red line. So our other angle has to be opposite of the red line. So it's going to be on the bottom. It's going to be either here or here. And it has to be outside of the sandwich. Okay, so if I place it right below the other red angle, if I place it right below this first red one, this would be a linear pair because they're next door neighbors and they make a straight line if you add them together. I don't want that. I want this one right here. Okay, it can't be up here on the top because if it's on the top of the red line, the transversal, then it wouldn't be opposite. So we have opposite of the transversal and they're both on the outside. Okay, the last scenario that we could have would be these two blue angles. So this blue angle that I'm drawing right now is on top of the transversal, the red line. I need one that's opposite. I need one that's on the bottom and on the outside of the sandwich. Okay, so these two blue ones would also be alternate exterior. Okay, now both of these are congruent. So they're the same angle measure. Doesn't matter if you have alternate interior or alternate exterior, both of these pairs are congruent. Okay. Now the last thing that we need to talk about is the definition of angle bisector. Definition of angle bisector. Okay, this one is very similar to the definition of midpoint. So I'm going to write that down. Very similar to the definition of midpoint. The only thing that's different about angle bisector is instead of working with a side, we're working with an angle. So angle bisector is going to use a segment that splits an angle into two equal pieces. So this uses a segment to split not two angles, it's just, it splits one angle into two equal pieces. I say pieces, I mean angles. Okay, so the definition of angle bisector uses a segment to split one angle into two equal angles. Okay, and the implication for this is that when you have an angle bisector, it creates two congruent angles. So equal, congruent is probably the better word. Okay. So how does this look? Okay, here's what a picture could look like. If we have points A, B, and C, points A, B, and C, and then I drew another point. We'll do it like this. We'll say this is D. Okay. From D to B, this segment would be the angle bisector of ABC. So let's write that down. So here in this specific example, DB is the angle bisector of angle A, B, C. So this is one way that you could see it. You could also see it like this. You could see this would probably be like a given statement. DB bisects angle ABC. And when you see this right here, you come over to your picture and you find angle ABC, you find DB, and then it's going to create two congruent angles. It's going to make this angle here, angle ABD. So angle ABD is congruent to angle, and it doesn't matter how you name it as long as B is the middle letter. We could say CBD. Okay, so when you see this right here, DB bisects angle ABC, that means that you do this right here. You do this guy right here. Angle ABD is congruent to angle CBD. Okay, you can also go the opposite way. If you see a picture that looks like this, where you have the congruent arc marks, okay, you can automatically know that BD is the angle bisector of these two angles. Okay, so that covers all of the definitions that we needed to talk about. So we talked about corresponding parts. We talked about congruency statements. We came down here. We talked about definition of midpoint, reflexive property, vertical angles, alternate interior, alternate exterior. We also talked about corresponding, and then the definition of angle bisector. Okay, so this is all in your notes. Out here to the side of these things, okay, you have these little hints that help remind you what they are. Okay, so please go back and make sure that you understand how to use these. Okay, but what we'll do is when we talk about all the things in this unit, we're going to be using those things quite a bit. So only thing that I'm going to require you to do is to give me the reasons, okay, for each one of these. So that's what you'll be provided with on a quiz. Is you'll just have to give the reasons, or you'll have to do something like this right here, where you have to tell me how these are congruent. So we'll talk about that in a later video, okay? But for now, I wanted to make sure that we reviewed some of our definitions before we started this unit.